We're going to make a new project. This is the project. We have the PCB, Chinese parts, then the schematic diagram, Q2 TIP41, but here we are using transistor of it's a MOSFET IRF530. But in the schematic diagram we are using transistor. Here we are using a MOSFET 530. Then with the LED, some of the LED, the coil. This is a Tesla coil. There is a plastic. And all other components. Let us assemble this Tesla coil.
It's not a game, it's a rich thing.
So we now have two transistors. One is TIP41 power transistor and IRF530 MOSFET. We have two transistors, MOSFET and power transistor. And as you can see here, we're going to connect the primary. This one is the primary coil, and then the secondary, which is this one, is the Tesla coil. Primary, secondary. This is the primary coil, and then the secondary. Now we have the Tesla coil completed, ready. We now connected the supply to our adjustable power supply, and we're going to supply the coil with 15 volts. Let us supply the circuit. We have now the power LED and the coil LED monitor. So we have now this 15 volts, 235 milliampere, 3.5 watts of power. So you can see here, did you see that? That is the corona discharge. This one. You can see the purple color. That is the corona discharge. Using the neon lights, it will turn on the neon lights. And then also with the compact fluorescent lamp. So this is a wireless power transmission Tesla coil using 15 volts, and the transistor uses TIP41 and MOSFET IRF530. Let us see the corona discharge, the arcing. Now we have the schematic diagram of Tesla coil using transistor TIP41 and IRF530 MOSFET. So we have two transistors, power transistor and MOSFET IRF530. Also, we are using a 15 volt supply for the circuit. So here we have the two resistor as a voltage divider. It provides the biasing to turn on this MOSFET. Okay, voltage divider biasing for the MOSFET. And then we have this capacitor for the interrupter. So this line is used for if we need to input any sounds or any music to the circuit, to introduce any music to the circuit or sounds. It modulates the signal or the signal of the gate to turn on this MOSFET. So this one is used for other purposes. And we have the another transistor here with fixed biasing resistor. This power transistor TIP41. And we have the power LED. This is the power LED. And the other LED, red. And we can see here, this is the power LED. This one is the coil or Tesla coil indicator. Whenever it has a signal or the coil is active, it will turn on the red LED. And then we have the capacitor. So into the output of the transistor, we have this primary coil, this red coil. It is 3 turns. And then the Tesla coil or the coil, the secondary coil is 350 turns. So the one line is connected to the base of the transistor, the other is hanging, it has no connection. So we can see here the corona discharge once we have the 5 volts at the input. So how does this circuit works? So the purpose of the two transistor is to make an oscillation or as a switch. So once the MOSFET is on, it will, once this transistor at the bottom is on, it will also turns on the MOSFET because the output side is connected to the output side of the two transistor is connected to the ground. They are interconnected. So when we bias this, will turn on, another one will turn on, will also turns on the output side. And because in order to produce an oscillation, because we're using a transistor that provides oscillation or it creates an oscillator, an oscillation, we need that the primary coil, the turns of the coil is opposite to the turns of the secondary. If this one is clockwise, the other one is counterclockwise. It must be opposite. The other one must be counterclockwise or the other one is clockwise. and also the soldering. That's the main problem of building this coil. So once this coil has an oscillation, it will induce a voltage to the secondary coil, making this to oscillate, because this one serves as a feedback to this transistor. So there's an oscillation going on from output to input, output, input. The coil, small voltage will become a high voltage, or a small voltage will produce a higher voltage into the secondary coil, and small frequency will produce a high frequency into the Tesla coil. And the discharge we have seen in here is due to the ionization, or the oscillation of the circuit, because it acts as if we have a capacitor to the ground because of the air. So there's an oscillation into the secondary, at the same time an oscillation into the primary. Keeps on oscillating, or we call that a resonant, resonating, or resonant, having a same frequency or resonating frequency. So that keeps the oscillation going on. So the purpose of the transistor is act as a switch due to the charging and discharging of capacitor through the output, inducing a voltage to the primary, and then transferring it to the secondary will produce a higher voltage and then higher frequency that make these two oscillate much greater than the primary, and then causing the corona discharge or a spark. There's a arcing into the tip of the coil because it is not connected. The other tip is connected to the base, the other tip is just hanging into the air. So that is the function of this circuit. Okay, what about this CFL? How does this lamp turns on whenever we make it closer to the coil? Why is that? What is the reason? So once we have the lamp, supposedly this is the lamp, and as it's getting nearer to the coil, it will turn on the lamp. And since this is the hand, my hand, so the arcing or the ionization or the discharge is flowing into the lamp, and then the hand act as a capacitor to the ground, since we are grounded. So we have a capacitive reactance or capacitive touch, or we have equivalent capacitance. So that's why it keeps on oscillating, because we are grounded, or as if we have our hand act as a capacitor to the ground, since our body is grounded. So it keeps on lighting or turning on this lamp, the CFL. So that is the reason why we have the lamp that keeps on turning on once it's getting nearer to the Tesla coil. Due to the air, the discharge from the air, and then captured by the lamp, and then since our hands is connected to the ground, it will turn on the fluorescent lamp.